Hello, today we are talking about vectors in calculus. And when we're working with vectors in calculus, pretty much everything that we know, of course we're talking about motion, everything that we know is going to be the same that we knew with our regular functions as we do with our vectors. So just a little reminder of um, vector notation. We can write a vector with an x vector and a y vector just in these little, they're not parentheses, they're sort of the greater than, less than sign. Or we can write our vector as x times I plus y times to j. And either notation is fine. Either one is accepted. I'm going to put everything in the first version because it's faster and easier. That's the only reason. So let's go ahead and start with example 1. A particle moves in the xy plane so that at any time t, the position of the particle is given by these two things. So we have an x, we have a y. So we need to find the velocity vector when t equals 1. So all we're going to do is, if we had a position function and we wanted the velocity, we would take the derivative. That's all we're going to do, and we're going to write it as a function, as a vector. So for my velocity vector, I would have for x 3t squared plus 8t. And then for my y, I would have 4t cubed minus 3t squared. So that's my velocity vector. And this question asked me to find the velocity vector when t is equal to 1. So now I just need to plug in my t is equal to 1. And so my velocity vector when t is equal to 1 is just going to be 3 plus 8 and 4 minus 3 is going to be 11, 1. Part B is asking for the equation of the tangent line to the graph at t equals 1. So I just found the velocity, and for the slope of the tangent line, the slope is just dy dx. Well, I've already found dy, and I've already found dx, and technically my dy would be multiplied by a dt in there, but basically we have dy, which would be my 4t cubed minus 3t squared divided by my dx, which is 3t squared plus 8t. But I only want the equation of the tangent line when t is 1. I've actually got that velocity vector over here. So I know the dy when t is 1 is 1, and I know the dx when t is 1 is 11. So I just took the y coordinate of my velocity, sorry, the y component of my velocity and divided by the x component of my velocity. There's my slope. Now I need to write the equation of the tangent line at this point. So the only thing that I have to do is find out my x and my y. So at t is equal to 1, my x is going to be um, t at 1, we're going to have 3 plus not 3, I'm using my derivative, I apologize. At t is 1, my x is going to be 1 plus 4, which is 5, and my y is going to be 1 minus 1, which is 0. So now I can write the equation of the tangent line is going to be y minus the y value is going to be this equal to the slope times x minus the x value. So in red is the equation of the tangent line. Part C is find the acceleration vector when t is 0. Well, I've already got my velocity vector, and I have this in blue right here. So to find my acceleration vector, I need to take the derivative of that. So my acceleration vector is going to be 6t plus 8 as the x component, and then 12t squared minus 6t is my y component. And then I don't really care about the actual function. I want to know what's the acceleration at t is equal to 1. And so when I work that out, I get 6 plus 8, which is 14, and I get 12 minus 6, which is 6. So here is my acceleration vector at time is 1. Moving on to example 2. We now have a particle. Position is given by this x component, this y component. Find the magnitude of the velocity vector at t equals 1. Now, the magnitude of the velocity vector is going to be a number. It's the length of that vector. Okay, so it's going to be a number, it's going to be the length, and its speed, so we know it's going to be positive. So all I'm going to do is I'm going to find the derivative of x, because I'm talking about my velocity. So I want to know the rate of change of x, and I want to know the rate of change of y. Sorry, that's my y. And that is 3t squared minus 6t. So that's going to be, if I wanted to write my velocity vector would be these two components, 2t plus 3 and 3t squared minus 6t. Now, I don't want the velocity vector. What I want is the magnitude of that, and I want the magnitude of that at t equals 1. So my velocity at t equals 1 is going to be 2 plus 3, 5, and 3 minus 6, negative 3. So to find the magnitude of this, sorry, that's an absolute value on the outside of my velocity at t equals 1, is going to be the square root of 5 squared plus negative 3 squared. So I can work that out. 5 squared is 25, and 3 squared is 9, and that gives me the square root of 34. So anytime you see magnitude, that's going to be a numeric value, will be positive, and you're just going to use Pythagorean theorem with your velocity vector. Moving on to example 3. Now we have two new x and y components. We've got some trig involved, and the path of the particle intersects with the x-axis 2 times. And then we're going to write an expression that represents the distance traveled by the particle between the two x-intercepts. Well, let's talk about what that means. The distance traveled between these two x-intercepts in terms of calculus is actually just going to be arc length. And we know how to find arc length. It's the square root of dx dt squared plus dy dt squared, definite integral between our two bounds. Now, the difficult part is usually finding the two bounds. Well, they've told us what we want. We want between the two x-intercepts. Okay, well, where do the x-intercepts happen? That's where the curve touches the x-axis. So we want to know where it touches the x-axis. Well, it's going to touch the x-axis whenever my y is equal to 0. So as long as the y value is 0, I should be touching the x-axis. So I'm going to set my y equal to 0, and that's going to give me that 2 sine t is equal to 1, and my sine of t is equal to 1/2. So thinking about my unit circle, or your special right triangles, however you do it, I need to know what t value, when I take the sine of it, I get 1/2, and that t value is pi over 6. And they gave me, an interval for t, is over here, and that is between 0 and 2 pi, so there should be another one, and it's in the next quadrant, so that will be also at 5 pi over 6. So I have my bounds. I just need to set up my arc length. Now to do that, I'm going to go ahead and find my derivatives. So my x prime is going to be negative 4 times negative sine of t, which is just 4 sine t. And then my y prime is going to be negative 2 cosine t. And then to find my arc length, I'm going to do the definite integral between the two x-intercepts, the square root of 4 sine t squared plus negative 2 cosine t squared dt. And again, I was just asked to do the setup. I was not asked to evaluate, so I am finished right there. Example 4. So in example 4, we have a position again, and what values of t is the particle at rest? Well, the particle is at rest when it's not moving in the x direction, and at the same time, it's not moving in the y direction. So I have two restrictions going on. I need my x prime of t to be equal to 0 And at the same time, I need my y prime of t equal to 0. Well, when I look at these two functions, I would solve the y one first because it's a little bit easier. So y prime of t is going to be 3t squared minus 6t, and I'm going to set that equal to 0. And when I do that, I can get t is equal to 0 and t is equal to 2. So at this point we have two options. I can take each of these values and plug it into my x prime and see if I get a 0, or I can go ahead and take my x prime and set it equal to 0. And it doesn't matter which way you do it, it's all the same. So now my x prime is going to be 6t squared minus 30t plus 36, and the question is when that is equal to 0. I can clearly see that at t equals 0, if I were to plug in t equals 0, my x prime is not going to be equal to 0. It's going to be equal to 36. So I might as well go ahead and plug in my 2. If I don't like these numbers, I'm going to divide everything by 6 first. So I have t squared minus 5t plus 6 is equal to 0. I plug in a 2 and I get 4 minus 10 plus 6 is equal to 0, and that works. So they are both the derivative of x and the derivative of y are both equal to 0 at t equals 0. Now, again, I could have solved this for when is that equal to 0, and I could have factored in, got t minus 2 times t minus 3 equals 0, and that gives me t equals 2 and t equals 3, and because t equals 2 is over here and here, that's the answer that I would like to choose. So moving on to the back. We are now on example 5. And we now have a velocity vector given to us, and we know the position vector at t equals 0 is 7, negative 4, and we want to find the position of the particle at t equals 1. I am going to do this two different ways, and the reason for that is the first way that you are initially going to do it is probably fine for solving this problem, but later on we're going to come to a problem where the second method is going to be the only way we can actually work that out. So starting here, we want to work on the position. So of course, if I had the position, I would take the antiderivative of velocity. So let's find our position function. And that's going to be the antiderivative of 3t squared, which is going to be t cubed, minus 4t, which is going to be minus 4t squared divided by 2, plus some constant. And then my y component is going to be 8t to the fourth over 4, plus 5t, plus another constant. Now, we know that the x component is 7 when t is 0, so that tells me if I plug in t is 0, that this thing has to be equal to 7. And if I do that, that tells me my c1 is 7. And over here, if t is equal to 0, that tells me that my y component is negative 4. So that tells me my c2 has to be negative 4. At which point, I should be able to find the position now at t equals 1. So I'm going to rewrite my position function. And again, I just need to erase because I'm going to do this in two different methods. So now my position function is t cubed minus 2t squared plus 7. And over here I have 2t to the fourth plus 5t minus 4. And I actually want to know, well, what is my position at time is equal to 1? And so that's going to be 1 minus 2 plus 7, and 2 plus 5 minus 4, and that leaves me at 6 and 3. So here is my position at time equals 1. Now, the other way I can do this is I know where I started from at time 0. So I'm going to do this in blue. What I could have said is, well, I started at 7 at time 0, and then I would need to add the definite integral from 0 to 1 of 3t squared minus 4t, and that would be the x component. There should be a dt on there. It's not quite going to fit though. And for the next component, I know I start at t equals 0 with negative 4, and I would need to add the definite integral from 0 to 1 of 8t cubed plus 5. Sorry that you cannot read that. That's a 5 over here. Plus, okay, I'm not sure why I keep moving the screen. Plus 5. And then we can work out these definite integrals, which is going to take a little bit more effort. I'm going to do the x term first. So I'm just going to do the x component first. It's going to be 7 plus, and we know the antiderivative is t cubed minus 2t squared from 0 to 1. And that is going to be 7 plus 1 minus 2 minus 0, which ends up being 6. And then I'm going to go ahead and do the same thing with the y component, which is going to be negative 4 plus, and this antiderivative we found was 2t to the fourth plus 5t from 0 to 1. And that will be negative 4 plus 2 plus 5 minus 0. And that, again, is going to be 3. And so that's just another way that we can write it as 6, sorry, that we can solve it, 6 comma 3. And again, as I said before, we're going to use the second technique, I believe, in the last problem. So let's look at example 6. We need a calculator for this. So if you don't have a calculator, I would appreciate it if you would go get one. I would like you to practice doing these things and storing values, which is a really important component of working with vectors. So we have a position function. Sorry, we don't have the position function. We have the derivative of each component. And at time 2, the object is at the position 7 comma 4. So we first have to write the equation of a tangent line to the curve at the point where t is equal to 2. So I'm going to actually leave this without using my calculator. So the slope is going to be dy dx, and I have dy, and dy is cosine t squared, and dx is sine t cubed. And I want this at t equals 2. So my slope at t equals 2 is going to be cosine of 2 squared, which is 4, over sine of 2 cubed, which is 8. I'm going to leave my slope just like that. Now, I have a slope, and I have a point where my object was located. That's my x comma y. So I'm just going to write my equation. Y minus 4 is equal to cosine 4 over sine 8 times x minus 7. So here's the equation of the line tangent. Next, we have a speed question. Again, speed is going to be a number. It's the magnitude of the velocity, and we want that at 2. Well, we have the two components. We've already done that in part A. We know the rate of change of y at 2 is cosine 4, and we know the rate of change of x at 2 is sine 8. So all we're going to do is work that out. I'm going to write it down before I put it in my calculator. I'm going to take sine of 8, my x component, squared, plus cosine of 4, my y component, squared, and I'm going to take the square root of that. So again, I'm going to pick up my calculator, make sure that you are in what mode? Radian mode. So we should be in radian mode, and I'm going to do the square root of sine of 8 squared plus cosine 4 squared, and sorry, I've got an extra, no, that's good. And then I want to close my parenthesis, I believe. And I get 1.1857. Part C, for what value of t between 0 and 1 does a tangent line to the curve have a slope of 4? So I know what the tangent line was. I actually found that in part A again. So you have that. So I'm going to go ahead and bring that down here. And I want to know, where is the cosine of t squared over sine of t cubed equal to 4? And then I want to find the acceleration vector at that time. Because the first thing I need to do is actually deal with finding this, and I need to do this on my calculator. So bring up my calculator, and I'm going to go ahead and graph these two things and find their intersection. So in y equals, I'm going to put, well, 4 is going to be one of my y's, and the second one is going to be cosine of x squared divided by sine of x cubed. And I need to adjust my window. First of all, they gave me a domain. They told me my t was between 0 and 1. So in my window, I'm going to change my x's to be between 0 and 1. And then I know what y value I'm looking for because I want to know, when is this equal to 4. So the other, sorry, I just want to look around y equals 4. That's all I care about. So I'm going to change my y min to be 3 and my y max to be 5. Again, I'm just looking around at 4. Here's my 4, so I'm just looking for, where does the curve cross this y equals 4, and I have it. And then I'm going to find the intersection. And my first curve is 4, my second curve is y2, and I need to keep going. My cursor is approximately on the intersection, and then ask my calculator, what is this intersection? Now, because I was asked to find the acceleration vector at this time, it's actually really important that I store this value. So before I even write this number down, I know it's 0.616 something. I'm going to quit the graph menu. I'm going to hit X, make sure it's still there. It is. I'm going to go ahead and store this in A. So I'm going to store that value in A. So anytime I need to use it, it is stored in A. So first thing is, does a tangent at what time? So this is at time 0.6164. I have stored this. Now I need to find my acceleration vector. So my acceleration vector, I had the derivative of x and the derivative of y. Now I need to take the derivative of those things. So derivative of x is going to be 3t squared sine of t cubed. And then the derivative of y is going to be negative 2t cosine, sine. I did not take the derivative at all. Slow down. Hold on. Let me repeat that. So for acceleration, it's going to be 3t squared cosine, my apologies, of t cubed. And for my y component, it's going to be negative 2t sine of t squared. So here's my acceleration vector, and I actually want to know, well, what is the acceleration at the time that I found, which I have stored in A. So I'm going to go ahead and pull my calculator back up, and I'm going to just plug this stuff in. So I have 3 alpha A squared, and then I'm going to multiply that by cosine of A cubed. And that's going to be the component for the x component for the acceleration. So that's 1.1090. I'm not going to write that down right now because my calculator is going to keep coming on and off the screen. So for the next one, it is negative 2a times sine of a squared. And that is my y component. So again, write those down on your paper. I'm going to go ahead and write those down on my paper now. So my acceleration vector is going to be 1.1090 comma negative 0.4573. Now I would have looked ahead to see if I needed those values for anything in the next problem, but I can see that I don't because it's just talking about the position. So for this question, it says I want the position of the particle at time t equals 1. We need to do this one using the technique that we used in example 5, but the second technique. So it's all about where I started and what have I done since then. So let's move down just a little bit. Sorry, we know we started at time equals 2. So I'm going to know that for my position, I'm going to start with at position 7, and that was at time is 2. I want to know the position of the particle at time equals 1. So I'm going to start at 7, but I need to take away the definite integral between 1 and 2 of the x component. And the x component, you can't see it on the screen, sorry. The x component is sine of t cubed. Then for the y component, I know I started at 4, and again, I need to take away the definite integral from 1 to 2 of my y component, which is cosine of t squared. And if you look at these, we cannot find the antiderivative of sine of t cubed. We cannot find the antiderivative of cosine t squared. So this is something where I'd have to pick up my calculator and actually evaluate these two numbers. So grabbing my calculator again, I'm going to calculate 7 minus the definite integral of sine of x cubed. And I want to do that in terms of x, and I'm doing that from 1 to 2. So this should be my x component, sorry, the position, the x value of my position is 6.7818. I'm going to do the same thing to find my y. So that's 4 minus the definite integral of cosine of x squared with respect to x from 1 to 2. And that gives me 4.4430. So again, now I'm going to write those down. So that is 6.7818 and 4.4430. So there you have it, little vectors with a little bit of calculus. That pretty much covers everything that we need to know about vectors. Bring any questions that you have to class, and I hope you have a wonderful evening.